One of the topics that you see on your learning notes is going to be sequences, and some of the sequences have specific names. For example, polygonal numbers. In this case, you already have seen square numbers. You know what square numbers are, but they actually are items that can be arranged in a square. That's what they call square numbers. They also are other type of numbers, like for example, in this one we're going to see triangular numbers. So triangular numbers is they're going to be they're items that you can arrange in such a way that they look like triangles. See, so those are the called triangular numbers, and there are many other polygonal numbers. You have pentagonal numbers, etc. So I do show you some in the learning notes. So, and some of the ones you do need to be familiarized with, besides the square numbers, is the triangular numbers. Okay, so for example, you have several problems in your workbook that does. In this case, this one is about logs, but you also have cannon bulbs that actually looks into like a triangular shape, but it says wooden logs are stacked in a triangular shape, always reducing one less than the one in the row below it. How many logs can you fit in a stack if the bottom row has 22 logs? So just like in this one is just missing the top one, but just like in this one, you have 4 on the bottom, and then on the top you have 3, and the top you have 2, and then on top of that one you will have 1. So that's how you create the triangles in this case, in the stacking of the logs, right? So you want to know what is the total number of logs when the bottom row has 22, right? So some of the strategies, problem solving strategies that we're going to be using in here involves making it simpler. So we're not going to start with 22. We're actually going to start with 1 and move from there. If you have, this is more targeted to elementary kids, then you want to be able, they can use some drawings, right, to help them view it. I always suggest to organize it on a table. And as you move along, you can use variables, etc. as you move in older kids, right? Older ages. So let's take a look. How would you do it? Now, you can also use interlocking blocks or cubes, like Legos and stuff like that. So you can use any of these because at the end, as long as they shape it this way, you don't have to use necessarily interlocking logs, right? So you have making it simpler. We're going to start with 1. Of course, if you only have 1 log, then that's just 1. If you have 2 logs on the bottom, then you can have a total of 3. If you have 3 logs on the bottom, then you have a total of 6. If you have 4 logs on the bottom, you're going to have a total of 10. So one of the things you want to start already doing is organizing the table, right? So when you have 1 on the bottom, the total number is 1. When you have 2 on the bottom, the total number you have is 3. And then again, I label it this way because this is kind of like the sequence number if you want to see it. 1, 3, 6, 10, right? That's how you would write it. But you can say for the purpose of your students, the number on the bottom and then the total number. You can always say that. So if the number on the bottom is 4, you have a total of 10. And if the number on the bottom is 5, what are we doing? We're basically adding the number on the bottom or the position of the term number to the previous total number of logs. See, 6 plus 4 is 10. 3 plus 3 is 6. 2 plus 1 is 3. So that means that for the fifth one, you're going to do what? 5 plus 10, which will be 15, right? 15, and so on. And again, the goal is for the student to reach all the way to 22. Now, they will have to add every single term. Like they have to create a table as long as 22 and then proceed with these steps to get it. And that's fine. Like if you are 4th grade, 5th grade, they can do it that way. Okay. Um, right. If you just want certain numbers, I would suggest don't make it too big if you want them to do drawings because it is tedious, right, to do this. But if you have 6, it will be 5. It will be 6 plus 15, and that's going to be 21, right? So again, that's the goal. So we have used the table. We then make it simpler. And we look for patterns, right? So now you have certain other ways to do it. Like I said, the goal is for you to get all the way to add all the way to 22. Like you will have to add from 1 plus 2 plus 3 plus 4 plus 5 plus 6 all the way to 22 to find the total number of logs, right? So there is a shortcut that a mathematician applied to his teacher's problem, and he was like a 2nd grader. And the teacher said, I want you to add all the numbers from 1 to 100 because he was really hyperactive. He was bored in class. So the teacher just wanted to give him entertain. So she just said, add 1 to 100. So what did the kid did? The kid realized that when he added the first and the last, when he added 1 and 100, he made 101. When he added 2 and 99, he made 101. When he added 3 and 98, he made 100. So he realized that adding the first and last and continue doing so, he always get a sum of 101. So the goal is how many sets of 101 are there between 1 and 100. So what are you going to do? You are going to divide the 100 by 2 because you're making pairs, right? So that means there's 50 sets. So sum of 101 times the number of sets of 101 I have. So once we do 101 times 50, you get 5,050. And then you have the answer. 5,050 is the sum of 1 to 100. Okay? And that was Gauss, the mathematician. He later on did a lot of other applications for math problems, etc. So if we apply the same knowledge that Gauss had to this problem, let me cover that one for now, right? So we added, right, the first and the last, which makes sets of 22, or 23, sorry. We make sets of 23. If we add 21 and 2, that makes sets of 23. If we add 20 and 3, that makes sets of 23. We add 19 and 4, that makes sets of 23. So ours is making sets of 23s. Now, how many sets of 23 are we going to have? So we have a total of 22 terms. We're going to divide it by 2, and that's 11. So we had 11 sets of 23. So what are we going to do? 23 times 11, and that gives you 253. So this is something that your fifth, fourth grade, fifth grades could do, right? They can realize that and then make the sets and then multiply it, and that's it. As you elaborate this problem, because this problem can be as simple as complicated as you want it to do, students can say, to find a generic version of it, they can say, okay, the sequence starts on 1 and ends on n. So what Gauss did is that he took the whole thing and he flipped it over, and then he added out backwards. So the two took the biggest number and added the first number, which is 1. Then took the second less biggest number and added to 2. And then they took the third less biggest number and added to 3, and so on until you end with 1. What do you see? You see that you always get the sums of n plus 1, right? The first one and the last one. And then you're just going to count, if you count how many n plus 1, if you add these two sets, you're going to have n number. So the total number of elements in the set. So if we multiply n times n plus 1, he has the sequence, the sum of the sequence twice. But I only want the sum of the sequence once. So what are we going to do? We're going to divide it by 2, right? Kind of what we did. We did 22. We first, in our way, we first divided by 2, and then we multiply by the sum, right? But the generic formula, this will be the generic formula for it, where n is the total number of elements in the sequence, and n plus 1 times n divided by 2 is the sum of all the terms starting at 1 and ending at n. Of course, this is not the goal for you for elementary kids, because again, this is just for algebra and up. The goal is for the students to understand that there are some other easy ways to do it, and this is one of them, as well as what the other stuff that we did, the table, the drawings, and then looking for patterns.